In flow monitoring, a monitor, which might actually be running on the router itself, records statistics per flow. A flow consists of packets that share a common source and destination IP address, source and destination port, protocol type, toss byte, and interface on which the packets arrived. A flow monitor can then record statistics for a flow that's defined by the group of packets that share these features. The flow records may also contain additional information, such as the next hop IP address and other information related to routing, such as the source and destination AS on which those packets appear to be coming from and going to based on the routing tables, as well as the prefix that those packets matched in the routing table. Flow monitoring is much less overhead than packet monitoring, but it's also much more coarse than packet monitoring because the monitor does not see individual packets or payloads. Therefore, it's impossible to get certain information from flow monitoring, such as packet timing information. In addition to grouping packets into flows based on the fact that they share common elements in their headers, typically packets are grouped into flows if they occur close together in time. So for example, if packets that share common sets of header fields do not appear for a particular time interval, such as 15 or 30 seconds, the router simply declares the flow to be over and sends a flow record to the monitor based on the group of packets that it's seen up to that point. Sometimes, to reduce monitoring overhead, flow-level monitoring may also be accompanied with sampling. Sampling builds flow statistics based only on samples of the packets. So, for example, flows may be created based on 1 out of every 10 or 100 packets, or a packet might be sampled with a particular probability, and flow statistics might only be tabulated based on the packets that end up being sampled randomly from the total set of packets.